Welcome to the fourth part of the seventh tutorial of the StemCell Game Engine, the scripting and logical object types. I was talking in the third part about actors. Today I'm going to talk about behaviors. So what is a behavior and why do we need it? Well, a behavior is a component-based implementation dealing with code, defining comportments for other component-based implementations. For example, we can have a pathfinding behavior attached to all units part of a strategy game, for example. The behavior constructed this way holds the scene structure and the various common units data into a single place and accepts as many actor of type unit as the user needs. It has also state properties and support like start, stop, pause, resume, which makes this implementation very easy to test, prototype and use. Note that component-based implementation of type actor can have many behaviors attached, and the process of attaching, detaching to or from a behavior is happening. It's happening at runtime. Can happen at runtime. It can happen also at the initialization phase, but we are not tied to some specific behavior attachment in general. We can attach, detach behaviors as we need. So now let's start by constructing a behavior we defined into the code. For this time we will go with a behavior which we wrote some C++ code for it because we need some specific execution. Of course, this code could have been written into the scripting, but we thought it's better now to show an example in which the user actually registers a behavior factory and the behavior type and how is this user defined behavior visible into the engine and the CellBuilder application. The type of behavior is called path animation. Is actually this behavior will use a series of 3D points and go from one to the other in a circular manner, and we'll always look at a certain specific point in space. It's a simple behavior. It's just for example purposes. Complex behaviors also can be constructed easily. So we will go and add a behavior, right clicking on the path animation and path animation factory, accept the name of the behavior. This behavior needs a few components in order to run properly. If we don't know exactly what components we need for this behavior, for example, if someone else from the team constructed the behavior and we don't have the documentation for it, we can build the logic, and in the bottom area at the build area we can see the errors and warnings raised by this behavior. It will tell us exactly what it needs in order to function properly. So the first error is no graph component attached to this behavior. So this behavior needs a graph component in order to move between points in the 3D space. So we already have the graph component created. I will attach the component to the behavior. This is camera animation path component is attached. Now we can build again the logic. We see the error no camera component attached to this behavior. We actually need the camera to walk this graph and to give us the exact results we are looking for. I will go and choose the main camera component. We have the camera component also attached. We will need to, if we want, actually this is not required, but if we want, we can attach a look at position component, which is a component of type vector of using three floats. This is a special type of component we didn't discuss before. Is a data component which doesn't hold any object from the engine, but it holds some data. In this case, three floats. Now we have the behavior, we have all the components we need. We still get a warning message which it tells us that there is no actor attached to this behavior. This behavior expects to get a placeable component, which is a camera component or an actor. In order to function properly, we can read the message, and there is no problem using it with only a camera and no actor at all. So I'm going to run this behavior. Now the behavior is not started yet. I'm going to press the run button. Now we can see that the camera, the main camera of the CellBuilder, it's actually animating into the scene. It will go from camera animated node to camera animation node. These nodes are part of the path component we defined. The camera is always looking at a fixed point, which is the point we defined by the look at position. Now it will help us to understand some of the properties of this behavior. These four properties are user defined. One tells us if we want to animate it or not. We can pause the animation if we want, but it's not really necessary. This property is telling us how fast the camera will move. I will go 1 unit per second, which is faster. Also, the node proximity, how close to a camera animation node needs to be in order to go to the next node. Now it's important also to see what kind of operations we can execute on behaviors. We have the four main operations which are interesting from our point of view, which is the start, pause, stop, and reset. For example, I can pause the behavior. Now I can change things in my scene. I can do anything I want and go back to unpausing the behavior and see the action continuing. I can also stop the behavior. It will get back into its original position. Can start it again. This is very important when testing and prototyping, and also when running the code. But when testing and prototyping, actions like pause, stop, reset are very important in order to get the results you need in as less as possible time. I think this example is enough for now. We have enough information about the behaviors, what are they, and how they can be used into our application. And I will wait for you at the last part of this tutorial, which will deal with graph-based objects. Thank you.